Hello viewers, here is another box fan that we're going to be cleaning and repairing for allegedly non-fan collector Russ. This is an uncommon model. It's a Sears branded Lasko, likely from the 70s, and this was probably the highest tier offered. It's a 3-speed with thermostat control and this fancy, I think they call this, or at least Lakewood I believe called this, the penthouse style control. And it's kind of counterintuitive because you have a thermostat, which would imply it's intended for window usage, but then when you put this bulky control panel on top, it becomes exponentially more difficult to put it in a window. So kind of a strange, maybe oversight in design concepts there. These are fairly uncommon, and not many of these left. They usually surface under Lasko or Galaxy. I have not seen, I don't think I've ever seen one of these under the Sears brand. I'm sure other people have, but I haven't. It's very dirty. Looks like it got wet at some point. Some busted slats, but nothing too bad. The Sears logo is still in very good condition. This will probably clean up pretty nice aside from the paint. It definitely needs to be repainted. There's some pretty serious rust on the bottom. I'm not going to be taking care of that. I'm just going to take care of the mechanics, and if Russ wants to strip all this rust off and do a repaint, that'll be his portion of the project. It's actually rusted so bad on the bottom I can't even slide it across the table. Here's the plug. I do believe this is the original plug. It's definitely seen better days, but the wire seems to still be structurally sound. It's not cracked or dry rotted, so if this is cleaned up, it'll probably be just fine to use. There's some signs of problems on this wire. I don't know what the heck happened here, but this looks like it might be through to the insulation right there. This is a strange failure. I don't know how that took place. There is some sticky electrical tape on here, which I imagine was probably originally wrapped around this portion for whatever happened to it. And this here isn't the greatest, so maybe the cord probably should be maybe at least cut out this section if you want to keep the original plug, which I would try to myself. Let me just cut out that section. Well, I'll leave that up to Russ. Motor's caked. This one came, I believe, from the same place as the other two box fans, as well as that Panasonic circulating fan that we serviced a couple weeks ago, or a couple months ago now probably. These are all stored in a very harsh environment. Maybe even outdoors, I don't know. This looks like it's been rained on. That, I think, is the remains of the informations. And of course there's nothing legible on there at this point, so I don't know what the model number is. I don't know any of the specs on these. These are older than what I'm really familiar with, so without having that information available on the tag, I just don't know it. Oh, there's some informations. There's some serious rust issues going on here on the bottom of this. This is a Sears electric fan, model 453-81310, and it's 2.4 the amps. And this is rough. It's not too far gone. You can sand this down and take a wire brush to it and repaint it, but that probably needs to be done soon, because it is getting to the point where that is now a structural integrity issue. But Russ is very good at fixing these kind of problems, so I'm going to leave that to him. I will take the crumbs out of the bottom of the cabinet, though, at least. That's not helping anybody with anything. So if I recall correctly, this tries to run, but it's locked up. So let's just check the current draw here. .8, that's reasonable for lock. 2.6, 1.2. Okay, so I think we're good. And the motor just needs some bearing work. Motor seems sound. Okay, let's begin. I'm not going to do all the work right now. I'm probably going to do it tonight. It's moderately decent out today. I'm going to do some stuff outside and do some work upstairs while it's still sunny and bright out. And then later on tonight we'll come back and work on this. But I want to get these guards started in the dishwasher because that's a couple hours a piece. So let's remove these guards. Oh man. Wow. I have never seen so many rust flakes inside of a fan before. I expect that I have air conditioner, but not in a fan. That is very, very bad. Even these screws are rotted out. It almost seems like it was just sitting in water or something at some point. Very unfortunate situation here. I wonder if these will even thread. Yeah, they are threading. So there's enough of something left there for them to grab onto. Wow. That one is almost not going to come out. I wonder if the blade's going to be badly stuck on this. This grill is very brittle. Definitely spent a lot of time near moisture. Wow, the blade is super brittle too. These blades are not normally made out of a plastic like this. That's kind of concerning. Well, I guess on the bright side, this will not warp, or it's unlikely to warp. There's one of the grill slats. I'll set that aside. There's more in there. And there are some more in here. We got 1, 2. It's some type of a clamp for something. 3, 4. Well, actually, we have quite a few of the grill slats still with us, so we can do some repair on that as well. We've got, I mean, they need to be cleaned. They're pretty far gone, but we got 5 of those, so we can do some repair. And this is the clip that goes over here for the stand. Wow, I have never seen a box fan like this bad. That's crazy. It sounds awful. I'm surprised these screws on the bottom are actually able to thread out still. This one's still good. Looks like the cord is passing through the guard in the back here. Now we can get a closer look at just how bad this really is in here. Curiously enough, this looks like it's been cleaned at some point. There appears to be a lot more dust inside the motor than there is in the blades and the cabinet and everywhere else. It's pretty well caked in there. And no oil ports on this one. That's not good. That is not good. Oh boy, that is really not good. What's happening here is the bearing is spinning inside the motor housing. So that means the shaft is just like welded to the bearing with rust. Okay. We're going to have our work cut out for us on this one. This is not going to be a simple fix. Oh man, that is not good. That is not good at all. Well, I'm going to start by just putting a couple drops of oil on there. Let it soak in for a couple hours and see if we can potentially get it to free up a little bit. Wow, that's not good. This is becoming a very, very, very grim situation here once that takes place. We'll see if we can even get the blade off at all. We'll start by taking that clip off. Meanwhile, half the stinking fan is on the table. This is almost like paper. What the heck? Whatever. I don't know what's going on there. Yeah, we've just lost a whole bunch of the frame. Yeah, there's definitely some paper in here though, because I feel like this is paper. It's almost like there's a piece of paper in there and it was holding moisture or something. That's kind of peculiar. I'm just noticing now the blade is it's like a lime green color. It's not yellow. I don't know if it was supposed to be like that or not, but that's what it looks like now. Oh man, this poor motor. Again, I gotta put all the screws and hardware somewhere else. It's gonna get lost in the rust here. All right, let's see if we can get this blade to come off. Man, it's not even budging. I bet it's just rust welded to that shaft. And on top of that, what is this? All right, this is going to be extremely challenging because we're limited by the kind of force we can put on this blade. More so than regular plastic plates, because this is the shattered plastic, so we can't put the same kind of force on this that we could put on like a a 223 blade or something like that, which will give, you know, has some flex to it. Wow, this is really not good. Oh man, that is locked solid. This bearing is completely locked. I'm gonna try, Russ. I will try to bring this thing back. This is so far gone. Oh man. This motor to cabinet, this whole thing is just holding by a thread. We can't even use the puller if it was safe, really, because this is designed in such an odd way that, no, see, this is not structurally sound enough to use the puller on. We're going to have to try a couple of heat cycles. Try a couple heat cycles on the shaft there and see if we can get it to come off that way. I might have to heat it up and let it cool, and heat it up, let it cool several times. And I think that the heat will be the safest approach because it's the least amount of force to be exerted. Heating up plastic is super sketchy, and I don't like this either, but we're going to try it. The problem is you really want to heat up the shaft more so, you know, yeah, I can see the rust. We need to heat up the shaft more so than the blade. And unfortunately, to do that, we got to heat up the blade first to let the heat pass through. We're going to have to stop in about 30 seconds because the plastic is starting to deform. Not even budging. Nothing. Well, we have to keep going. I have to get it hotter than I'm comfortable with. With a metal blade, this is a very, very easy solution because you can heat up the metal blade as much as you want, and you can actually get a decent expansion and contraction cycle and break the rust bond. You can't do that with plastic. This is nowhere near as effective on plastic as it is on metal. I don't like the way that's starting to look. Yeah, we're gonna have to stop. I don't like the way that plastic is starting to look now. It's starting to deform. And if we lose the integrity of that part of the plastic, we're done. Okay. We made some progress there. Something shifted. Yep, it's shifted. Let's keep going. Okay, we're almost there. It's almost off. I gotta get something to put under the fan so I can keep pushing it down. I'm gonna set up these pieces of wood to sit the cabinet on so I can get some more space underneath there. Make sure that this does not interfere with where the blades are gonna go. All right, hopefully we can just get it off now. Okay, good. Okay, the blade was removed successfully. Now we have this poor beat up motor, which is just barely clinging to life. So the front is good. The bearing is still okay in the front. It's the back that's a problem. So what's happened here is the shaft has become so welded to the bearing that the bearing itself is now spinning inside its holder. So we're gonna go back at this with the heat again and see if we can free that up. Now this we can get pretty hot without too many concerns. There is the potential to trip the thermal fuse, but if that happens, we know why, and we'll just replace it. I'm gonna get this good and hot, and then we'll try to tap the shaft from the front, see if I can get it to break loose. Okay, it's coming back. See, the shaft is moving back now. Okay, our zoom spout fell over. I'm going to push that back in. Okay, let's see if we get a drop of oil on there now. Going to get some oil inside that that area there. It's starting. It's starting to spin on the bearing now instead. Get that oil to work in there. Keep the heat on it. Okay, let's put a drop in the front too. I'm sure that's dry as well. I need to get this to run before we take it apart. I'm going to plug this in now and see if we can get it to power up. This cord is making me a little nervous. Make sure that it's not spinning in the back. Okay, so you can see it is a little bit. So we don't want that to happen. We do not want that bearing spinning in the surface there. Just gonna keep adding some oil in hopes that it will free up. I just need to get it to run for a few minutes so I can polish the shaft down. Gotta make sure this is not getting too hot. I think we're still in the clear. I want to keep an eye on the power draw, make sure nothing weird happens. Just let it try to draw that. We only got a couple minutes to run it like this because that's almost at LRA. Come on. Dang it. It's getting there. We're making progress. It might just be so gummed up that it's not going to cooperate. What we might have to do is just take the front out, not slide the bearing off the surface, or not slide the front bell off, just leave it in place, clean the back, and then put it back together, and then spin it up to clean the front. It's getting better, but this is, I think it's going to have some caked up, dried up oil in there, which is part of our problem right now. And then of course, given this is a shaded pull motor, it's got very little torque to overcome this. motor's heating up. We're going to have to stop soon. There we go. That's what we wanted. That's operating properly now. Okay. Wow, it's still working good. Well, that's a bit of an exaggeration. While it's still working, let's get the front of the shaft. And we got a little while longer to work with this. Let's get this shaft cleaned off while it's running properly, and then we'll get it all split apart and cleaned up. Alright, that's about as much as we're going to be able to do for now. It's getting pretty hot. I don't know if this is thermally protected or not. Don't really want to find out. So we're going to stop there. I think that we're probably copacetic now to take this apart. So, alright, that's good. We got through that pretty quick. That is definitely going to be, that was the most challenging part of this, getting the blade off and getting this bearing freed up enough to the point where it'll work properly. And it is now operating properly. Actually, it's freed up pretty nicely now. Definitely got some worn out thrust washers in there. Alright, so that's good. We are past, or we are out of the real danger zone. I was definitely concerned about getting the blade off, but that's good we got it off. And it's still sound. I guess there is some part of it here that's it's integral on the inside. As you can see, this did in fact kind of melt a little bit from the heat, but that was necessary. We were not going to get this off without the heat. I don't think that we were going to clean that up without the heat either. Okay, we're back. It's the next day. I had to tend to some other things yesterday. So let's see if after sitting for some time, is this still working? No, it's not working because it's shut off. It's not working. It's very stiff because it's cold now. But that should be okay, because I think it's clean enough that it's going to slide off. So let's get this disassembled now. There's going to be a couple extra steps on this one to get to where the switch is located because it's inside this fancy apparatus here. I think before we do that, I'm going to take a quick break and vacuum up some of this dirt, especially out of the cabinet, so that we don't keep spreading it all over the place while we're working, as this is starting to make quite a mess here. Okay, now that there's not quite as much of a mess, let's get that motor out of there so we can clean that up and service those bearings. This is going to be a rough one. This is in very, very poor condition. But I think if we've gotten to this point, we'll be able to get it running properly again. So I've never worked on one of these before, but it looks like there's going to be some nuts on the top that hold the front part of it in place, and hopefully it'll pivot back on these pieces back there and give us access to the controls. I certainly don't want to have to flex any plastic tabs at this point in time, because all the plastic on this is very brittle. Even just unscrewing this out of the plastic studs is making me kind of nervous. Looks like this is detaching nicely. Perfect. Okay, that has completely detached. Now we're going to remove the switch from the assembly here so we can remove the wires from the switch safely. Here's our knob. We'll get that cleaned up. It looks like another default size bolt to release the switch. Definitely some rust involved here. Alright, so before we go any further, let's stop and make a diagram of how this is set up. Don't want to lose the information. Okay, so we're looking at the control panel like this, and here's our switch. It is now how should we represent this? If we look at the back, well, we'll just use the numbers. So 3 is red, 2 is blue, and 1 is black, and L is white. And it sits in here such that white is in the top right. It's so important to write down a diagram of how things go when you take anything apart that's not standard. And this, although it was probably standard 60, 70 years ago, it's certainly not standard now, and you're probably not going to find this information anywhere. Not that it's all that difficult to ohm out the motor and find out what speeds go to which, but just save yourself the trouble and write it the heck down. It's so easy. Alright, now we're going to take the wires off of the switch so we can take the switch out from this area, or rather so we can take the wires out from this area. This switch is designed the same way as the newer ones. There's just a little tab in there that holds the wire. You use a very thin set of pliers to push the tab back to release the wires. This one appears to be stuck. There we go. So now we can pull these wires through here, which will allow us to detach the motor from the frame. For the safekeeping of that top piece, I'm going to put this back and close it just with one screw, just to reduce the likelihood of it getting damaged while we're moving the unit around. That's all comprised of very brittle plastic at this point. As far as the motor's wiring is concerned, there is still one more piece that's holding it in place. The common wire. I don't think that this tape is necessarily supposed to be here. We're going to open this up and pull up this wire here, which is our connection to the common. And we're going to try to uncrimp this. Sometimes that can be done, sometimes it can't. We're going to try. So it's crimped that way, so we'll try to uncrimp it by applying pressure in the opposite way it was crimped. Well, unfortunately, this has become brittle and it just broke. So we were not able to successfully uncrimp this. I really don't want to have to cut it because there's hardly any slack here to begin with. If we have to cut this, it's going to be very difficult to get this back, to get it back on. It looks like I was able to partially uncrimp it. Now we just need to get it to come off. Okay, good. I was able to get it to come off. So we can't reuse that, but at least it didn't strip out the, or didn't cause the wires to have to get restripped. And then we would have had an issue with the slack. Okay, so now we should be able to remove the motor from the housing. Here's a neat screwdriver that I like to use on bolts like this. I don't know what the brand is on this thing. There we go. It's a hex lock screwdriver. Part number 2.875.660 and 3.285. What does that say? .106 it looks like. And it's really neat because the way it works is different size nuts will press in only certain parts. So it ends up being like a multi-size nut driver, and for small stuff like this is really all you need as opposed to getting a full socket set out. It can be a little flaky to get it on. Sometimes it doesn't align very well. And of course, now that I'm demoing it on camera, it's not going to work at all. Go figure. You're kidding. I wonder if this is an issue of this is metric versus standard. It's kind of grabbing, but it's not, it's like in between sizes. Unbelievable. This does work. I use this thing all the time, but I think it's working good on this screw. But it is not working on these. Okay, well, then we'll just have to use the adjustable wrench like we usually do. Brought that in because I thought that would be helpful. But not in this case, I guess. Because these are not the right size for this one either. No. Stupid. Stupid bolts. Okay, the motor is now detached from the cabinet. Let's make sure we don't misplace those 3 bolts. 1, 2, 3. And here's the filthy motor. And yes, this whole time it has been plugged in with the power bar on, even though this stupid thing is off half the time I'm trying to use something. Okay, it's time to get this motor opened up. We have more pesky bolts that we don't have the right size air quality issue driver for. So we're still playing with the stinking adjustable wrench. Put these back on there so we don't lose them. Alright, now we got to get this to open up. Let's see if we can get this open easily. Nope, it's not going to come open easily. Try to avoid this practice because it's very risky, but we're going to have to pry it open this way. So we got to get the front part off first and then the back, because the lead wires pass through the back. That we're getting the back separating first, which is no good here. This motor is very, very stuck. Okay, sounds like we just broke the seal on the front there. Okay, now it's starting to come off. Good. Okay, and we did sand that down enough to get this off easily. And as you can see, front's not too bad. The issue is going to be in the back. And there on the inside of the shaft, towards where the rotor is, you can see all the gummed up sticky lubrication, which is what's causing our problem. Okay, so we know this one is the back because the wires pass through the hole. It's not possible to assemble this backwards. I suspect that this might be an early Marco motor. Lots of plastic in here, which is interesting. I've never seen one just like this before with all this plastic. Very strange. And I don't know why this is like this with the insulation sheathing on there. So it's pretty dusty. Probably yeah, we should probably take this outside and blast it with the compressed air to get the bulk of it off first. And then we can go back inside and do some fine cleaning. Then we'll varnish it, and then we'll get on to the bearing situation. Kind of sounds like a bell. Ding! Much better. The bulk of the dust is gone. But we're going to do a little more fine cleaning on these windings before we varnish them, just to get any more visible dust accumulation off. As great as the compressed air is, it's only good for certain types of accumulation. When you have any kind of grease or grime, like if this is used in a kitchen, used in a shop, a garage, etc., the dust does not come off easily. And I think we have some of that here. Some of this dust is not really coming off too easy. There's a lot of dust down in this crevice here, which I think that we're probably just going to have to leave. A lot of dust down in here. Maybe I can grab it out with this. A lot of pretty loose wires on this stator, which is what I usually find to be the case with these. Alright, that's good enough. Yeah, some very, very loose wires up here. And this is why we revarnish, because you get stuff like this. That is no good. You get vibration, buzzing noises. So loose winding, loose wire there too. Loose wires here. Not good. So this one's pretty bad. But again, this is what I usually see. So let's take this back outside. We'll varnish it. I gotta reattach the custom varnishing tool here. This is very important. We'll attach this during the varnishing process, which will keep us safe, just like a blue plug. I don't know what's up with this. This is kind of weird. I'm going to move this out of the way for the varnishing, because it's not going to get the varnish onto the winding if that's in the way. But this doesn't really have any loose wires there, not much loose there. I guess I'll just leave it where it is. It's kind of a strange design choice. Okay, let's take this outside. We're going to use the spray off EL600 clear, not red, insulating varnish. Okay, the varnishing is complete. Do not spray varnish onto your camera. We're going to do some work at the cleaning area now. We're going to clean the blades. We're going to clean the motor endings. Ding, bells. And then we'll clean the bearings and then get those relubricated, and hopefully that will solve all our bearing problems. Get all that sticky stuff out of there. So we have to be kind of careful with this blade as we clean this because of the material this is comprised of. It's a very delicate plastic that will shatter as opposed to bend like a Lakewood 223 blade or so forth. This will just shatter. So we have to clean it kind of carefully. Make sure that we're not putting any kind of force on it in any direction. Wow, look at that clean up. This blade is going to be the best looking part of this fan. What is that? It is coming off, but it's taking a lot of effort. Phenomenal. It's too bad the rest of the fan is so junky because the blade is going to look like brand new. It's a very interesting color too, very unique. Wow. Kind of sounds like a bell. Wow. Well, that came out nothing short of fantastic. Well, maybe someday the rest of the fan will look just as good if Russ decides to repaint it. Could restore it very nicely. Alright, now let's clean the end bells. Ding! Kinda sounds like a bell down here. I guess we'll use this piece still. This is not going to get anywhere near as good, because this is a lot of paint loss here. But we can improve it. A lot of rust too. I don't like to put a lot of moisture on these because, you know, there's always a risk of some water goes into the bearing or something like that, and that's no good. I think that's all we're going to do on that because of the moisture situation. And it's a diminishing return anyways. There's not much paint there left to clean off. So I'm going to spend all the time cleaning it up and it's not going to look any better. Okay, we'll do a little bit more cleaning towards the end, just some wipe downs with the melamine foam on the cabinet, you know, where the controls are, but that's most of the cosmetic clean that we're going to do. I will leave the rest of that to Russ. He's very good at it, and he seems to enjoy it, whereas I don't. So we'll make a good team on this one. I'll take care of the mechanics, and he can take care of the cosmetics. Okay, now we're really getting to the root of the problem here, which is in our bearings. So this is the rear bearing, which is going to be worse than the front, I think. Actually doesn't look all that bad. Maybe it's all sticking to the shaft instead. That's pretty bad. We'll get all that cleaned up. And you can see this definitely has some hours on it. That thrust washer is pretty worn down. Oh man, that's super sticky. Very sticky. Any? No more thrust washers in there. You always check, because sometimes you get a residual thrust washers just chilling in there, and then it gets misplaced unintentionally. We're going to clean with some isopropyl alcohol as well, because this was so bad that will start dry. Air quality alert. This is cleaning up easier than I expected. Maybe this will be an easy one. They do exist, but they're pretty rare. And usually once the equipment gets this old, it likes to put up a fight. Okay, get all that caked down oil off of there. Okay, not too bad. I'll go back over that again with the isopropyl. Make sure those don't get canceled out. That we can cancel out. Don't need that anymore. Yeah, the front one's not bad at all. It's funny how sometimes it's only one side, and it's not always one or the other. This is the front. These end bells are identical, with the exception of the rivet being installed for keeping the cord from being up against a surface with sharp edges. So I guess you can put it on backwards, but that would result in, or rather you still have the rivet there to indicate which one is which. Alright, let's put a little bit of isopropyl in there to clean it out further. This is 70% isol. I don't know what the other part is. Water? I don't know. I'm not a chemist. Here we go again. We need a chemist to explain what's the other 70% of that. No, a fair bit came out, so it's a good thing we're falling back with this. I never used to use isopropyl in the bearings, but Kevin suggested that we should, and I think that was a good suggestion. Might actually do that again, because we're still getting junk coming out of there. that's looking pretty good now. The outside surface not so much, but it is important to clean the inside surface because this is where the thrust washers will ride, and if that's still sticky, you're still going to have problems. Alright, we'll call that one ready to go. Well, I'm not just going to call it, it is ready to go. It is clean and it is fixed. So this one is the back, so this one in theory might be worse. This is where the problem was. Although, interestingly enough, it looks like it's perfectly fine. Okay then. Now this is sitting kind of loose in here, which is not ideal, but I don't think that it's a problem because if the bearings are free and working properly, it's not going to build up enough friction to spin in there. But this is definitely able to spin a little bit more. I mean, I can't really get it to spin by hand just doing this, but if I put a lot of force on it, I can get it to spin in there, which is not the way it's supposed to be. Curiously enough, this one you could actually open this up fairly easily because this is held on by these tabs instead of rivets. So this is surprisingly serviceable. Alright, now we'll move on to the shaft. Actually, let's do the thrust washers first. Not even going to bother to try to clean those dry. We're going to need the isoprisol. Isoprisol is a very good cleaner. And this is only 70%, it's 30% something else. I think you can get stronger concentrations of it. Now we'll make sure we get this very clean. I have to scrub pretty aggressively on this. And these are a little bit brittle. These can definitely break. That's why I am, wow, it's actually cleaning off the ink on the package there. That's why I'm cleaning it on the bag like this, on the table, as opposed to trying to do this in midair. I can apply force pretty evenly and safely when it's down on the table here. Alright, that looks pretty good. Not sticky anymore. This one's pretty sticky. And it's also very worn down. Now some people, there's two different trains of thoughts here, and one is not necessarily correct over the other. There's valid reasoning for both. Some people say put these on in the same exact way they came off, and some people say reverse them. If you're having problems with the motor, in the sense that you've got bearing rattle or something like that, I say reverse them, because one side is worn down one way, the other side's worn down the other way, and the wear is going to take place differently. So to an extent, the other side of this washer is pretty much like new. So if you turn this around, you're going to get a whole new surface to work on, kind of. And a lot of times that will take a rattly motor and make it quiet. This one is being very difficult to clean. This one is not looking as good cosmetically, but it is not sticky. Alright, now let's get the shaft cleaned up. We'll spin up the shaft in this apparatus to clean it. I like to put a piece of paper around the shaft before I put it into the machine, just to protect it from getting nicked by the chuck. And we're not going to use any isoprisol. We're going to use Simichrome polish. Okay, looks pretty good. Now move on to the bottom, which is worse. That was where our problem was. This is coming out of the thing here. This is just about to fall out of there. Let's see if I can wrap this up before it falls out. No, actually it's still fairly secure in there. Certainly felt like it was fixing to fall out. Okay, here's the product. Much better. Nice and clean, ready to operate properly. Now we're going to add some oil. These have no oil ports, so they have to be lubricated from the inside. The only way to properly lubricate this is to disassemble it. So where the oil goes, it goes in between the bearing and the end bell. Ding! These are what we call sintered bearings. And there is a wicking-like material inside here that we're filling with oil right now. And that will release the oil into the bearing. Sintered bearings have microscopic pores on the inside, which the oil will pass through over time, heat cycles in operation. So this kind of serves as a like a continuous lubrication method. Okay, it's pretty full. It takes a lot of oil. Probably 15-20 drops if it's completely dry like this. Now we'll add a couple drops on the inside of the shaft as well, just to give it something to start with. Put a couple drops of oil on the shaft here. Go ahead and put these thrust washers on. So I'm going to put the less worn one on the back, because that's where the more worn one was, and put the more worn one on the front, which where the less worn was. Whatever. That's such a stupid thing to try to say. Okay. Now we are ready to reassemble. I'm going to go wash my hands so I don't get oil anywhere else, and we'll put it back together. It really sounds just like a bell. Yeah, I don't hear much difference. Anyways, we need to get the stator down from the ceiling. It should be all dry now. It's dry enough to assemble anyways. Here's what it looked like now. Certainly better than before. So here's where the wires need to go. Nope, that's not the back. This is the back, because we need that grommet. Okay, now we have to make sure that the screw holes align, otherwise we're not going to be able to put it back together. So, looks pretty good there. I might as well get one or two of these out just to make sure that they pass through. It's a good thing we checked because it's not in complete alignment. Okay, now it's in good alignment. So now we'll kind of close this up. And we'll stick the rear portion of the rotor into place. And we'll put the front on. And this orientation does not matter on this because it is there's no oil ports. But I'll just align the two grommet holes together, put our bolt back in, make sure it's all lined up properly. It seems to be. Let's close it up. Alright, that looks pretty good. Let's get our 3 bolts back in place. You can kind of vaguely see on this where the bolts originally were. You can tell there was one right there, there was one here, and then there was one here. Now I'll put the nuts back on. Torque these down. They don't have to go very tight, just firm. Click. Click, using a torque wrench here, and not a digital one. Click. Okay. So now let's see what we've got here. You might find that the shaft is still stiff. No need to panic, that is fairly normal. Ironically, the last one I serviced and this one, they're both pretty much perfectly aligned immediately. But if it's not, just take a screwdriver and tap on the shaft in a couple of different directions, and that will, the shock from that will align the bearings properly. These are self-aligning bearings. That's pretty good. It's operating at a very low friction state. This now glides in and out with practically no resistance. Turns with no resistance. This is in very good shape now. Just to finish it off, we'll add a couple drops of oil in there, maybe just one or two, so don't spill everywhere. There's plenty coming out the back. And this is good. Ready to go back together. It's a shame this is so badly rusted out, but I have no doubts that rust can fix that. Alright, let's get this motor remounted into the frame, or what remains of the frame. Now sometimes when you tighten these bolts, it messes up the alignment of the bearings. Same procedure as before. To correct that, just a couple taps with a screwdriver should get that back into alignment. This doesn't have to be crazy tight either, just snug. The click. The click. The click. Let's see. We do not seem to have messed it up at all. Maybe slightly. Alright, that looks pretty good. Alright, that's running properly. Now we can reconnect the wiring. I'll have to get a new connector. I wonder what kind of connector we should use for this. I think I might use something that's straight instead. A little easier to work with. I think this should be good. Hopefully I can crimp it at this angle. In retrospect, I probably should have crimped it before putting on the motor, because then I could have moved it down to get more slack temporarily. But I suppose if I can't get it, I can always just re-detach the motor and put it on. Okay, that's lining up pretty good. Unfortunately, it's a copper to some kind of alloy connection, which is not ideal, but that's just the way it is. Oh, well, that gets a 0. What the heck? Why did that take place? I feel like this is not the crimping tool I used last time. I thought last time I was doing this I discovered I had a different tool. Now I can't remember. Well, that's good. It made a good connection. Oh wow, look at that. That's just about to fall out of there. That's nutty. Especially because this can be, it's not polarized, so this could end up being the high side. It's a 50-50 when you plug it in. So I think that for the sake of safety, we have to fix that. We're going to replace that one as well. Ouch. Well, that uncrimped pretty nicely. Maybe I can just crimp it back. Now I'm going to change it. I think that this is a better setup. I'm going to change it to that. That's too long. Probably too short now. Oh no, it's actually just the way it should be. Okay, we got good connections. Slip it back in behind there like that. It's kind of dodgy how that's like that. Maybe we'll put a tie wrap there to keep the wires from being able to potentially move forwards into the path of the blades, because that would certainly be catastrophic on a blade set like this. Same thing with up top here. It's really kind of flaky actually. I also don't like how the wire is sitting on a sharp edge like that. That's really flaky. Now we're going to reference the diagram. So we know that the red went to number 3. And blue went to number 2. And the black went to number 1. And the weight we did not change. Stick that back in place. Get that re-secured. And for some reason that does not seem to be lining up properly. That's not the wrong screwdriver. I don't know why I got that out for. Huh. It sure seems like it's lined up properly. Oh, come on, stupid. Get in there. Jeez. Okay, switches back in place. Put the knob back on. Back on. All right, now I'll put this whole control panel frame thing back on. This just kind of folds up like that. And then we've got some screws that will go in on this side. And they are quite long. I think they are unnecessarily long. I think something about a third the length of these would have been adequate. I don't know, but then again, I guess it does have the whole weight of the fan because that's part of the handle, so maybe it's warranted. Alright, now let's see what we should do about this wire. I think we got to do something about it. It's kind of risky the way it is now. It definitely could very easily come into the path of the blades. Oh, why do you keep all those pieces of wire? Because sometimes I use them. So what I want to do here is I'm going to put that to the back like that. And then I'm actually going to kind of indent that in there like that. I think that's pretty good. And at the top here, maybe we'll put a piece like this. Okay, that's good and secure now. Move on to the bottom. Do pretty much the same thing. I think we'll make use of these holes here to pass through a little clip like this. Some more stinking sticky electrical tape. And I'll put one more down here like this. And I think that's pretty secure in terms of preventing the wire from potentially coming loose and interfering with the blade set. Okay, very secure. Actually, you know what? Duh. And I didn't realize that we have those holes there as well. You sometimes do something and minutes later you realize there's a better option. Instead of this thing. This works, but there's a better option. Just use the little hole like we did everywhere else. Alright, now I feel like the wire is definitely not going to come out and interfere with the blades. I don't think it would be physically possible at this point under any reasonable foreseeable circumstances. And I'm going to go put that wire back in the garage and we're going to save it again because it might come in handy for some other project. Okay, I think we're ready to test it out, see how it's working. Yeah, this cord, I forgot about the dodgy cord. Well, I'm going to leave that to Russ to take care of as well. It's, if he wants to change or not, that's a matter of personal preference. I don't think it's unsafe to use. It's definitely a little dodgy, but I think it's going to be okay for now. Well, that's certainly running much better than it was before. Not that that's a very high bar to clear, but very good. Here's the blade, cleaned up very nicely. Okay, it's gonna put up a little fight here, trying to go on. There we go. That's a pretty cool looking blade. Interesting color. And look at what the melamine foam does. The shine that's on there. I didn't put a whole lot of time into cleaning that up. It cleaned up very easily. Very nice. And as you can see, the bearings are very happy. Alright, let's get the clip on. The blades do fit looser on the shaft now than they did before because we have cleaned all the rust and everything off the shaft. So it's going to be imperative that the clip be on there at this point. Clips are a pain. I wonder if there's a specific tool for these kind of clips that would grip them better than pliers. You know, hold on to it more securely than the pliers do. And this works, but it's certainly not ideal. Alright, that's on. One last check of the motor's operation. Sounds good. Let's put the guards back on. That's so nostalgic, the back of the motors being open like that. I remember that with the 3733 that we had from 99 or 2000. Gosh, there's a serious air quality in here tonight. Air quality issue. All right. Now we got some pretty badly rusted screws that should probably be replaced at some point. Some water over there. Can't believe that that's actually threading still with that much rust on both the screw and the frame. Now you'll notice here that these guards did not warp. They're made out of a different type of plastic. And they were also better fitting in the machine. There we go. It is all back together. Very cool looking fan. This would clean up decently with the melamine foam. I'll probably do that later. This just needs to be glued back on there. Shouldn't be too difficult to find a knob that's similar to that. And with some new paint, this will be looking pretty good. Certainly landslides better than it was before. Front and back. The blade looks more yellow on the back, and then it looks kind of like a lime green on the front. I'm not sure if it's supposed to be like that or it's sun damage. Who knows? Alright, we'll do one final test run, and then this will be ready to go back to its original fan collecting owner. I'm going to do a separate video of this before I give it back to him. We'll analyze the performance and everything. Just want to check to make sure that it's running properly at this point. Power is reasonable. It's out of balance, but it's a Lasko product, so it should be no surprise. Oh, that almost tipped over. Yeah, everything's reasonable on the power specs. And aside from the balance, everything seems copacetic.